Hey, Mr. Harridan here. We're going to go over writing and balancing chemical equations. One of the key concepts that you need to understand this unit here. Okay, we know that the reactants or the reagents are on the left side of the equation. The products are on the right side of the equation. Total number of atoms on one side of the equation will equal the total number of atoms on the other side of the equation. This is called the law of conservation of mass. Okay, that is what it is called. Okay, steps for writing a chemical equation. Step 1. Write the correct chemical formula. Just so you know. If the formulas are wrong, it is not good at all. Play. Never mind. It will not play.
I'm sorry. I'm Peter.
That's great. Okay. Plus sign means adds or reacts with. Elements by themselves have no charge. That's very important. Watch out for the diatomic elements. I bring clay for our new house. Those are the diatomics. There is a reaction arrow for yields. You have to write the correct formula for the products as well. No correct formulas, you're not getting any credit for anything because everything else is wrong. Okay. You balance out the entire equation by using coefficients. Do not change the subscripts because that changes the formulas and that makes the formulas wrong. Usually use metals first, polyatomic ions, nonmetals. Always save hydrogens and oxygens for last. Can't put a coefficient in the middle of a compound. Oh, they're state symbols. Did I tell you they're state symbols? There is S for solids. There is G for gases. L is for pure liquids. And AQ is for aqueous solutions. Okay. Single elements, when you look at the color periodic table here, you know most of your metals. Those are solids. Mercury and bromine are the only liquid elements there are. And most of your nonmetals are gases. Okay, the periodic table behind me, the red ones are gases, the blue ones are liquids, and the black ones are solids. Okay, ionic compounds. Remember, ionic compounds have a metal and nonmetal. Okay, they are solid in synthesis reactions and decomposition reactions when I show you those, which will be the next video after this. Okay. For ionic compounds, when water is present, you have to use the solubility rules. So you use these rules. So these are rules for ionic compounds in single replacement reactions and double replacement reactions, when you will see those eventually. Okay? Basically, you have to find the right square for your compound. That's how this works. Now remember, ionic compounds have a metal and a nonmetal. Okay? So for instance, this is rule 1. These rules will be given to you. You do not need to memorize these. All group 1 salts, so anything that has a group 1 element in it, like Li3PO4, NaCl, those fall under this square right here. You would put an AQ. Ammonium salts, like NH4 F. That would be aqueous. Nitrates, because this is row 2 when I do it. This is row 3. Nitrates, chlorates, perchlorates, and acidates. Those are all soluble too. So if I have something like magnesium nitrate, that is soluble under row 3. Rule 4. Chlorides, bromides, and iodides, except for silver, mercury, and lead. Okay, so this is how rule 4 works. This is the first rule. We have some exceptions. So if I have something like iron chloride, iron is not on this side, so we stay over here. So this is aqueous. These all get the aqueous symbol. If I was doing Wi2, tungsten 2 iodide, aqueous, because it's not over there. Now, when I put chlorine with silver, like this, AgCl, that is a solid. Now I'm on the solid side, because I have to have the 4 rule and the exception to it. If I have PbBr2, Br is over here, but Pb is an exception. This will be a solid, which is the driving forces of some of our reactions. Rule 5, fluorides. So if I have something like barium fluoride, nope, I don't want to do barium fluoride. Bad example, Mr. Harridan. Bad example. Aluminum fluoride, AlF3. Fluoride is here. Aluminum is not on the other side of rule 5. So we stay over here and we put an AQ after it. So I'm supposed to put AQs after all of these. Okay. But if I have magnesium fluoride, now I have the fluorine with the magnesium, that would be a solid. Okay. And I just keep going down these rules until I find something. So rule 6, say I had iron sulfate. Iron sulfate would be an aqueous, because I'm still in a square and iron is not over here. But if I have like calcium sulfate, that would be an S. Okay, that would be a solid, because I have sulfate with calcium, so now I'm over here in this square, which is the S square. Now we get to rule 7. Now notice that these are the insoluble compounds here. So if I have hydroxide with zinc, ZnOH2. Zinc is not on the other side of rule 7 here, so this would be a solid. Okay. Or if I had AuOH3. Gold is not on this side, is not in group 1, so that would be a solid. But if I put OH with Ba, for instance, like BaOH2, now I have OH with Ba, that is an exception, so that is now an AQ. So you have to figure out which square you're working in here. Or if I had LiOH, LiOH would be AQ because that is in group 1. Now if you can't find a rule, for instance, there's no rule for calcium phosphate, because all other monatomic and ions fall under rule 8. So this would be a solid. But if I have phosphate with lithium, lithium is in group 1. Why did I write that in purple? I wanted to write that in green. Write that in green, Mr. Harridan. Li3PO4, AQ. Now I'm in this square, that is AQ. Okay, now let's see if we can write some reactions on our own here. Here we go. Let me find some solubility rules so I can do this with you. Pause.
Well, can't we just talk? What about the Twinkie?
Yeah, what about the Twinkie? The Twinkie is one of the greatest food products known to man. Okay, anyways, here we go. Here's how I do this. Circle all the chemicals that we find here. So we have zinc, and that pen stinks. Hydrochloric acid, zinc chloride, hydrogen gas. Reacts with is usually a plus sign, to produce is usually an arrow, and this is a plus sign. So we write down the chemical formula for zinc. Zinc is Zn. Okay, plus hydrochloric acid, which is also known as hydrogen chloride, right? Because hydro-ic came from ide. So hydrogen chloride is HCl AQ, right? Make sure you're checking the charges. +1, -1. So we're good there. To produce zinc chloride. Zinc is Zn, chloride is Cl. But you remember zinc is +2 and chloride is -1. So the correct formula for zinc chloride is ZnCl2. And hydrogen gas is H2. Because it's one of the diatomics, remember that. Diatomic element has to be H2. Okay, now we're going to balance the reaction. Usually I just look at them and balance them. 1Zn, 1Zn, that's good. 1H, 2H, we need a 2 right there to balance. 2 chlorines, 2 chlorines. That is a balanced chemical reaction. Zinc is a metal, so that is a solid. Hydrogen is a gas because it says it's a gas. Plus it's red on the periodic table, so we know that hydrogen's a gas. Now we have this reaction is a single replacement. I will tell you how I know later, but it has an element in a compound, so I know it's a single replacement. So it comes down to using these solubility rules for zinc chloride here. So I find group 1, so we're down to the chloride rule. And then zinc is not over here, so zinc chloride would end up in this square like this, and this would be an AQ. So that is why this gets an AQ right there as well. Okay. First reaction done. 3 more to go. We're on a roll. Okay, here we go. I'll ask this again.
What high school did you go to?
You still went to Allen High School because I'm your teacher. Okay. Anyways, I'm in the Bill Murray phase right now, just so you know. Circle the chemicals. Phosphoric acid is reacted with a solution of sodium hydroxide to produce sodium phosphate and water. Okay. Here we go. Gotta start off with phosphoric acid. If this was a gas, this would be referred to as hydrogen phosphate, because it came from 8, right? So we write down the formula for hydrogen is H, and remember phosphate is PO4. H is +1, phosphate is -3, so this is H3PO4. Is reacted with sodium hydroxide. Sodium is Na, hydroxide is OH, because that's a polyatomic ion. +1 and -1, that equals 0. Okay, sodium phosphate. Sodium is Na, phosphate is PO4. Sodium is +1, phosphate is -3. So this is Na3PO4. And I know you're going to write down water as H2. I don't have to. This is a double replacement reaction. For double replacement reactions and single replacement reactions, water is HOH. Do not write down H2O. Why? Because it gets harder to balance. Okay? This is a double replacement reaction. Did I tell you it's a double replacement? Yeah, it's a double replacement. Here's how I know, because I'm a smart man. H goes with OH, Na goes with PO4. That makes a double rainbow, which makes a double replacement reaction. Okay, time to put in the state symbols here. We know all acids are aqueous. Okay? NaOH, Na falls under the group 1 rule right here, because Na is in group 1, so this is aqueous. So this is going to be an aqueous salt right there. Sodium phosphate falls under the group 1 rule as well, because it has sodium. So this is going to be AQ as well. And then water is HOH. So this is a liquid. We have to balance the reaction here. 3 H's here, 1 H here. So there's a 3 right there. 1 PO4, 1 PO4, 1 Na, 3 Na, so we need a 3 here to balance. 3 OHs, 3 OHs. The key is I don't count my H's and OHs as the same. This is 3 H's here, and that is 3 H's over there. That is how that reaction is balanced. Okay, next one here. See if you guys can do these. I will circle the chemicals first while you guys are trying. Chlorine gas. Chlorine gas is Cl2, because remember, chlorine is a diatomic. Plus lithium iodide. Lithium is Li, iodide is I. Check the charges. It's ionic. +1 and -1. The correct formula is Lii. Goes to produce lithium chloride. Lithium is +1 and chloride is -1. So this is LiCl. Plus iodine is I2, because this is diatomic. Okay. It's a balanced reaction. 2 chlorines here, 1 chlorine here. So I'm going to put a 2 there. 1 lithium here, 2 lithiums here. So I'm going to put a 2 there. 2 I's, 2 I's. Let's put in some state symbols. Chlorine says it's a gas, so we put in a G. Iodine says it's a solid, so we put in an S. Guess what? This is a single replacement reaction. That means we need to use the solubility rules for the other compounds. So lithium iodide. Lithium is in group 1, so it falls under this square right here. That would be aqueous. Lithium chloride falls under group 1 salts as well. So that would go under this square right here. So that would be aqueous as well. Okay, last one here. Let's see if I can speed this one up here a little bit. Solutions of silver nitrate and barium chloride are mixed. The products are silver chloride and barium nitrate. Okay, here we go. Silver nitrate. Silver is Ag, nitrate is NO3. +1 and -1. Barium chloride. Barium is Ba, chloride is Cl. +2 and -1. BaCl2. Silver chloride. Silver is +1, chloride is -1. AgCl. Because again, writing the formulas is the most important thing. Barium is Ba, nitrate is NO3, plus 2, minus 1, Ba, NO3, 2. Once over here, once over here, 1 NO3 over here, 2 NO3s over here. You're going to put a 2 in front of the AgNO3. But that now gives me 2 Ags. So now I have to put 2 in front of AgCl. 1 barium, 1 barium, 2 chlorines, 2 chlorines. Guess what? This reaction is double replacement. So we gotta check the rules. Okay. So here I go, checking the rules. AgNO3. AgNO3 is going to end up in this square right here because that's the nitrate rule. So this is aqueous. So this is AQ. Barium chloride. Okay, it's not group 1, it's not ammonium. This is the chloride rule. Barium chloride ends up in this square right here. It is aqueous. Okay. Silver chloride. Chloride is here, but silver is over here. So silver chloride actually ends up in this square over here. That is an S. And then barium nitrate ends up in this square right here because there's no exceptions to the nitrate rule. So this is AQ. Okay, guys are champions. The legend's out.